that Unit 7 is probably one of the easier units that we're going to be covering, and it is a very short unit. Okay? All right, so looking at number 1, it says select all the numbers that are greater than 2. So if you did the math, you would figure out that it was B and D. If you get it right, leave it alone. If you get it wrong, just put an X on it and circle the new answer or the correct answer with your color. Number 2 says select all the numbers that point A could reasonably represent on this number line. So you should have D and E. Why do none of the others work? Like 1.5. Why does 1.5 not work? Okay. It's a little bit past that halfway point. If you did pick 1.5 or 1.5, I can understand why, because it's very close. But it is a little bit past that one. All right, so for number 3, it's asking you to give, write the number at A as a fraction. For B, it says write it as a decimal. And then for C, it says write as a fraction and a decimal. So you should have half for A, 1 and 25 hundredths for B, and then 2 and 3/4, and then 2 and 75 hundredths. So again, make sure you have the correct information there. Thumbs up when you have this written down. Alright, sliding over to number 4. A should be greater than, B should be equal to, C should be less than, D should be greater than, E should be equal to, and F should be less than. Alright, so when you have that written down. So thumbs up when you have 4 complete, so I know that I can move on. Alright, and then it says calculate each difference. So make sure when you are subtracting, what do you have to do with the decimals? Aiden? Gotta line them up. Alright, so when you do your subtraction here, you should have with 2 and 2 tenths. Flip your paper over. For B, you should have 12 hundredths, or 0.12. And for C, you should have 8 hundredths, or 0.08. Alright, so looking at number 6, it's giving you points for, or it put points on there and you had to write the coordinates for each one. Remember, this is your X, this is your Y. You always go to the left or right first, and then up or down second. Alright, so for A, it should be 3, 3. For B, it should be 1, 4. For C, it should be 4, 1. For D, it should be 2, 0. And for E, it should be 0 and 1.5. Again, thumbs up when you have this information so that I know we can move on.
Can we borrow Gemma, Ford, and just Gemma?
Gemma? Okay. Alright, slide over to number 7. So it says on the X coordinate grid, the the X-axis represents the age of a plant in weeks, and the Y-axis represents the height of the plant in inches. So A says after 1 week, the plant is 2 inches. Plot the and label the point A. So you're going over 1, up 2. Does everybody understand why we went over 1 and up 2? Okay. For B, it says after 2 weeks, the plant was 4 inches tall. Plot and label point B. So you go over 2, up 4. Again, does everybody understand? Any questions? All right. C says after 3 weeks, the plant was 4.5 inches tall. Plot and point C. So you go over 3, up 4.5. Oh, that should be B. Now, D, it doesn't matter where you put it on your y-axis, but it doesn't matter where you put it on your x-axis. Why? Why does it matter? Jonathan?
Because in this sentence it says after 4 weeks.
So after 4 weeks. So no matter what, your x has to be 4, but your y can be any number on the y-axis, but your x must be a 4. Okay? All right, questions? So what do you think about unit 7? It's gonna be okay? All right, go ahead. For now, we're just gonna fold this. Actually, no, take the time to glue this in so you don't lose it. Don't glue it all the way down, just put a little bit of glue on the bottom of your page so that you can fold it and then see the back side if you need. Alright, and then slide over and get this little piece of paper out that I passed out to you guys. This is gonna be our notes for today. Hopefully you do have some time today that you can add a little bit of color to your note page. But for now, we're just gonna use our, which color? This thing. Pencil? Oh no, I forgot to show the video. I always forget to show the video. I'll show it when we're done, before you guys go. Alright. So we are gonna be taking some notes today. And we're gonna be talking about rational numbers. So a rational number is any number that can be expressed as a quotient or a fraction. And any two integers where the denominator is not a 0. Alright, so couple things within this little definition. The word integers. What is integers? Anybody know? What does the word integer mean? Because if you don't know what integer means, then how do you understand the definition? What do you think? Not the answer. Okay. Lily?
Positive and negative numbers as long as they're whole.
So it's a whole number. Okay? So it cannot be a fraction, cannot be a decimal. It's gotta be a whole number. Okay? So now that you know what integers is just another name for numbers. Or for whole numbers, sorry. Alright, so looking at these different types of numbers. So for integers, a couple of examples would be -5, 17, 294. So any positive or negative number that is whole. Alright, fractions. This one is pretty self-explanatory. So any number that is a fraction. So we have 1/4, let's do 2/3, 11/12. Alright. Mixed numbers. Someone give me another mixed number. So we have 3 and 1/8. What's another one? Zoe B?
5 and 4/5.
fits. Alright, what about another one? So Gemma,
9.5.
9.5. Okay, alright, what about percentages? Alright, so we have 71%, Kylie,
45%.
25%, what's another one? Krishna, 99? Alright. Now, this one is a little bit different. Terminal decimal. We're gonna terminal decimals. Maybe.
Decimal that doesn't repeat over and over again.
So it doesn't repeat? Okay. Why do you say it doesn't repeat?
Instead of repeating decimal over.
Alright, so using some context clues on your paper, right? So we have terminal decimals and then right underneath it we have repeating decimals. So yes, you are correct. It's one that does not repeat. Alright, so we have 9 and 6/500, so let's do a negative 5 and 2/10. And then let's do 75 thousandths. Alright, and then obviously repeating decimals are ones that repeat. So we have negative 4 and 3/10 repeating. Let's do 1 and 2/10 repeating. And then 3 and 345 thousandths repeating. Now, how does this last one that I gave you work? So 3 and 345 thousandths repeating. What does that mean, Jonathan?
If you look at the line numbers, that means it's a percent 345, 345, 345, 345.
Right, so it's not just one number that repeats. Sometimes we're gonna have 2 numbers or 3 numbers or 4 numbers that repeat in a decimal as well, okay? Because a lot of times we think, okay, a repeating decimal is just the same number over and over and over again. But understand it's also the same pattern over and over. Alright, so rational numbers can be what? What can they be? Based off of the numbers that we just wrote up here, what do you notice? What can they be? Yes. Positive or negative. And then 0 is a rational number, and the reason 0 is a rational number is because 0 is an integer. And can be represented by placing a 0 in the numerator of any fraction. Alright, so a little fun fact. Irrational numbers cannot be written as a fraction of 2 integers. Their decimal never, sorry, I can't spell, terminates and never repeats. So it just goes on forever. Alright, so as a group, now I want you guys to go through, is it rational? So you guys are gonna look through these numbers and you're either gonna check yes it is, or sorry, you're gonna check oh yeah, or not a chance. Okay? So I'm gonna give you like a minute, it shouldn't take us too long. And then we'll go through it together. Alright, go ahead and get started. You're working together, that means you should be talking. Alright, let's go ahead and go over this.
Yeah.
Alright, so we're gonna do stand up, sit down to get a little bit of movement in our legs. So they said 6 and 8 tenths repeating was a rational number. Obviously, hopefully we all agreed. Alright, so stand up if you said negative 31 is a rational number. Alright. That is correct. Have a seat. Stand up if you said 1 and 2, 4, 5, 8, 2, 3, 9, dot, 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 dot is a rational number. This is not a rational number. Why is this not a rational number? Jonathan.
Because rational numbers, it says repeating, but there's no specific pattern. If it has no pattern, like pi, that would be a rational number.
Good job. Alright, stand up if you said 42% is a rational number. Alright, 42 is a rational number. Have a seat. Stand up if you said 1,290 is a rational number.
Yeah, move them up today, move them
Yeah,
up.
trying to get them moving around a little bit. You ready for it?
It's okay.
Yeah.
I need to read something like that.
Okay. Isaac, just bring a pencil with you, babe. Alright, yes, that is a rational number. Have a seat. Stand up if you said 2 tenths is a rational number. I said have a seat. Okay, now I can stand up if you said it's a rational number. So, ooh, we had a split group. One said yes, one said no. Alright, so let's talk real quick. So, Kaylee, you and Wyatt are saying yes, it is. Why? Okay. So it's not a terminal decimal, but it's not a repeating decimal. Okay? And then why did you guys say it wasn't? You what? Okay. This is a rational number. Alright, stand up if you said 1/5 is a rational number. Yes, you are correct. Have a seat. Stand up if you said negative 9 and 23 thousandths is a rational number. Yes, that is correct. Stand up if you said 8 and 1/10% is a rational number. And if you guys are not sure. Okay. Is it a percentage?
Yeah.
So then it's a rational number, right? Alright. Stand up if you said 5 and 8, 9, 8, 9, 6, 5, 2, dot, 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 dot is a rational number. So why not? Why is this not a rational number? Camden.
It's not repeating.
It's not repeating. Alright, next one, 5 and 78, or 78, God bless. 5 and 7/8. Stand up if you said this is a rational number. Yes, that is correct. Alright. So the next one we already know is not a rational number, right? 5 and 3, 4, 3, 4, 3, 4, dot, 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 dot. No, it's not. No, it's
No, it
not.
has to have one number for the decimal.
It's repeating. It's a pattern. It is repeating.
So it's a repeating decimal. Repeating pattern decimal.
I don't say that wrong.
You are right. Alright, stand up if you said 1 is a rational number.
It's one. A repeating of the number.
Alright. Technically 0 is the beginning of numbers. 1 is right after the beginning of numbers. Alright, and then the last one, stand up if you said the square root of 2 is a rational number.
Oh, that's square root? Do that.
I thought it was
I
just
didn't
a-
know. I thought it was very, like,
Yeah, I thought it was a
if
very-
it's a rational number, I'm bleeding either.
It is not a rational number.
I should know because on the irrational numbers it says square root of 7.
What?
Oh, so you, again,
Gives you the answer.
listen, using some context clues, Candace said, well, he said, well, I looked over here and I saw in irrational numbers that it's got that little symbol of the square root. Alright, so this is your note page for rational numbers. We are going to show, I'm going to show you a quick video that I forgot to show you, I'm so sorry. And then I will show you what the rest of your day is going to entail. So hush.
Negative numbers, and also learn a bit of how do we add and subtract them. And when you first encounter them, they look like this deep and mysterious thing.
If you want, while this is playing, just so it doesn't tab it long for the normal, you can add some colors to your notes page. Or you can just sit and listen.
When we first count things, we're counting positive numbers. What does a negative number even mean? But when we think about it, you probably have encountered negative numbers in your everyday life. And let me just give you a few examples. So before actually I give the example, the general idea is a negative number is any number less than 0. Less than 0. And if that sounds strange and abstract to you, let's think about it in a couple of different contexts. If we're measuring the temperature, and it could be in Celsius or Fahrenheit, let's just say we're measuring it in Celsius. And so let me draw a little scale that we can measure the temperature on. And so let's say that this is 0 degrees Celsius. That is 1 degree Celsius, 2 degrees Celsius, 3 degrees Celsius. Now, let's say that it's a pretty chilly day, and it's currently 3 degrees Celsius. And someone who predicts the future tells you that it is going to get 4 degrees colder the next day. So how cold will it be? How can you represent that coldness? Well, if it only got 1 degree colder, we would be at 2 degrees. We know we have to go 4 degrees colder. If we got 2 degrees colder, we would be at 1 degree. If we got 3 degrees colder, we would be at 0. But 3 isn't enough. We have to get 4 degrees colder. So we have to actually go 1 more below 0. We have to go 1 more below 0. And 1 below 0, we call that -1. We call that -1. And so you can kind of see that the number line, as you go to the right of 0 on the number line, it increases in positive values. As you go to the left of the number line, you're going to have -1, then you're going to have -2, you're going to have -3, and you're going to have, depending on how you think about it, you're going to have larger negative numbers. But I want to make it very clear. -3 is less than -1. -3, there is less heat in the air than -1. It is colder. There's less temperature there. So let me just make it very clear. -100 is much smaller than 1. Or sorry, much smaller than -1. You might look at 100 and you might look at 1 and your gut reaction and say, wow, 100 is a much larger number than 1. But when you think about it, -100 means there's a lack of something. -100, if it's -100 degrees, there's a lack of heat. So there's much less heat here than if we had -1. Let me give you another example. Let's say in my bank account today, I have $10. Let me do this in a new color. So let's say today I have $10. Now let's say I go out there because I feel good about my $10, and let's say I go and spend, I go out there and I spend $30. And for the sake of argument, let's say I have a very flexible bank, one that lets me spend more money than I have, and these actually exist. So I spend $30. So what's my bank account going to look like? So let me draw a number line here. And you might already have an intuitive response. I will owe the bank some money. So let me write this over here. So tomorrow, what is my bank account? So you might immediately say, look, if I have $10 and I spend $30, it's $20 that had to come from someplace. And that $20 is coming from the bank. So I'm going to owe the bank $20. And so in my bank account, to show how much I have, I could say 10 minus 30 is actually negative $20. So in my bank account tomorrow, I am going to have negative $20. So if I say I have negative $20, that means that I owe the bank. I don't even have it. Not only do I have nothing, I owe something. It's going in reverse. Here I have something to spend. No one owes, if to some degree, if my $10 is in my bank account, means the bank owes me $10. I have $10 that I can use to go spend. Now all of a sudden, I owe the bank. I've gone the other direction. And if we use a number line here, it should hopefully make a little bit of sense. So that is 0. I'm starting off with $10. And spending $30 means I'm moving 30 spaces to the left. So if I move 10 spaces to the left, if I only spend $10, I'll be back at 0. If I spend another $10, I'll be at negative 10. If I spend another $10 after that, I will be at negative 20. So each of these distances, I spent $10, I'd be at 0. Another $10, I'd be at negative 10. Another $10, I would be at negative 20. And this whole distance right here is how much I spent. I spent $30. So the general idea, when you spend or if you subtract, or if we're getting colder, you would move to the left of the number line, the numbers would get smaller. And we now know they can get smaller than 0. They can go to negative 1, negative 2. They can even go to negative 1.5, negative 1.6. You're getting more and more negative the more you lose. If you're adding, if I go and get my paycheck, I will move to the right of the number line. To the right of the number line. Now with that out of the way, let's just do a couple of more pure math problems and just think about what it means if we were to say, let's say 3 minus 4. So once again, this is exactly the situation that we did here with the temperature. We're starting at 3 and we're subtracting 4. So we're going to move 4 to the left. We go 1, 2, 3, 4. So that gets us to negative 1. And when you're starting to do this, you really understand what a negative number means. I really encourage you to visualize the number line and really move along it depending on whether you're adding and subtracting. Now let's do a couple of more. Let's say I have 2 minus 8. 2 minus 8. We'll think about more ways to do this in future videos, but once again, you just want to do the number line. You have a 0 here. We're at, let me draw the spacing a little bit. So we have 0 here. We're at 1, 2. If we're subtracting 8, that means we're going to move 8 to the left. So we're going to go 1 to the left, 2 to the left. So we've gone 2 to the left to get to 0. We have to move how many more to the left? Well, we've already moved 2 to the left. To get to 8, we have to move 6 more to the left. So we're going to have to move 1, 2, 3, 4, 5, 6 more to the left. Well, where is that going to put us? Well, we're at 0. This is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. So 2 minus 8 is negative 6. You have to move 2 minus 2 would be 0. When you're subtracting 8, you're subtracting another 6. So we go to negative 6. We go 6 below 0. Let me do one more example, and this will be a little less conventional for you, but hopefully it will make sense. Let us take, and I'll do this in a new color, let me take negative 4 minus 2. So we're starting at a negative number, and then we're subtracting from that. And if this seems confusing, just remember the number line. Just remember the number line. So this is 0 right here. This is negative 1, negative 2, negative 3, negative 4. So that's where we're starting. Now we're going to subtract 2 from negative 4. So we're going to move 2 to the left. So we're going to go, if we subtract 1, we will be at negative 5. If we subtract another 1, we're going to be at negative 6. We are going to be at negative 6. So this is negative 6. Let's do another interesting thing. Let's start at negative 3. Let's say we have negative 3. Instead of subtracting something from that, let's add 2 to it. So where would this put us on the number line? So we're starting at negative 3, and we're adding 2. So we're going to move to the right. So you add 1, you become -2, but if you add another 1, which we have to do, you become -1. You move 2 to the right. So -3 plus -2 is -1. And you can see for yourself that this all fits our traditional notion of adding and subtracting. If we start at -1 and we subtract 2, we should get -3. It kind of reverses this thing up here. -3 plus 2 gets us there. Then if we start there and we subtract 2, we should get back to -3. And we see that happens. If you start at -1, right over here, and you subtract 2, you move 2 to the left, you get back to -30. So hopefully it starts to give you a sense of what it means to deal with or add and subtract negative numbers. But we're going to give a lot more examples in the next video. And we're actually going to see what it means to subtract a negative number.
Alright. Go ahead and in your notebook, turn the page. Title the next blank page. Rational numbers, practice problems in today's state. And then stand up when you have this copy down. We're not coloring or anymore, we're doing what I asked. You should. All right, have a seat. For your practice problems today, you are going to have to go to campus. Don't go right now, just follow along. So when you go into Canvas and you click on Math, starting on the home screen, you are going to go to Modules. You're going to scroll down to Tuesday, you're going to click on Tuesday. We did our pre-assessment, watched our video, did our notes. You are clicking on the practice problems on rational numbers. So you need to put this into slideshow or present mode so that you can actually use the buttons and do it correctly. So you're just practicing. So you're going to click on it, and then it says write an integer to match the following description. So you're legit just writing a debit of $15, a deposit of $155. Then you can check your work. So yes, hopefully everybody gets the right answer because you do have the option to look. Then if you're good, you hit go to the next question, and it goes to the next set of questions. Okay, this should not take you very long. This is all you're doing for the rest of the day. This will be checked. It needs to be done in your notebook. What that means is, if I'm in my notebook, I'm gonna do number 1, and I'm gonna write what a debt or a debit of $15 is, what that would look like. So that would technically be negative $15. That's all I'm having to do. Again, it's not a lot of work. Okay? Any questions with what you're doing? When you are finished, you're either working on Imagine Math or you're working on Lexia. Please do not let me catch you on anything else, other than if you're done with everything and you want to do typing. Okay? Put your hand down. I'm about to answer your question. You just stay in your lane over there. All right. Any questions with what you're doing for the remainder of today? Alright, go ahead, get started. If you wanna work around the room, you can.